Hey guys, today we're going to take a look at some of the other trig functions and how to graph them. Okay, so we're going to start with the cosecant and the secant function. Okay, so remember, cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. Okay, so here's what we're going to do. To graph a cosecant, I'm actually going to graph a sine function because we're familiar with that. We know what a sine looks like. So a sine function goes through the origin, and then it goes up to a high point of 1, back to the x-axis, -1, and then back up to the x-axis. Okay, same sine graph we've graphed this whole time. This graph goes up now. I'm going to connect these dots, but I'm not going to connect them with like a solid line. I'm going to do a dotted line, just so you can see the graph, but this isn't our actual answer, so I'm going to have a dotted line here. Okay, so that is a sine graph. I could do a second cycle going this way. It would hit there, it would hit here, up and down. Okay, so that's a sine graph. Now, the cosecant is the reciprocal of that. Okay, so what does that mean? Well, let's look at a few specific points here. So, for example, right here we have a sine value of 0. So what's the reciprocal of 0? Well, that's undefined. So what's going to happen, every place that we cross the x-axis, the cosecant of that angle is undefined. So what we're going to have is a vertical asymptote. We're going to have a line that our graph will never, ever cross because that value is undefined. We're not allowed to divide by 0, so we're going to have a vertical asymptote here. We'll have one here. The y-axis will be a vertical asymptote. And here. Okay, so we've got these vertical asymptotes, which means, if you look down here, I'm going to ask you about the domain and the range. It means we're going to have some domain restrictions as well. So, for example, x cannot equal 0, x cannot equal pi, x cannot equal 2 pi, or negative pi, or negative 2 pi. Okay, so what's the domain? Well, it would be the set of all x's such that x does not equal 0 plus, well, we got pi, we got 2 pi, I'm assuming 3 pi, 4 pi, 5 pi, all those pi's, the negative pi, the negative 2 pi, any multiple of pi, so pi k, that's how we say that, is not going to be in our domain. Everything else is cool, but that's where you're going to have vertical asymptotes, so those are going to be some domain restrictions. Okay? Now, what's going on in between them? Well, look at this number right here. Look at the high point of our sine graph. What's the this is 1. What's the reciprocal of 1? Well, it's still 1. So that means our graph hits this point. But as our sine graph is getting lower, okay, so imagine I'm here, this is the high point, and these values are getting smaller and smaller and smaller. So let's say this is point. Let me think of this a different way. Let's say this is 1/2. Okay, so this is 0, this is 1. Let's say this y value on the sine is 1/2. Well, the cosecant would be the reciprocal of that, or 2. Let's say that this point down here, let's say we're at 1/4. Okay, we'll say this is 1/4. The reciprocal of that would be 4. So I'm already going off my graph here. This graph, the cosecant, is going to mirror this sine, but it's going to curve up, 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 and then it's going to follow that vertical asymptote and get closer and closer and closer to it. Over here, same thing. Where the sine graph curves down, because the values are getting smaller and smaller, the reciprocal of those are going to be getting bigger and bigger and bigger and bigger. And so you get this little section, kind of looks like a parabola. It's not a parabola. Parabolas keep getting slowly wider and wider and wider as they go up, whereas this is going to get trapped and follow those vertical asymptotes. Okay? everywhere you have these vertical asymptotes, that same thing is going to occur in between them. So like down here, instead of the graph curving up and up, this is going to curve down and down. It's going to do the reciprocal of that. Okay, same thing over here. Same thing here. That is a cosecant graph. The solid little parabola looking things you're seeing, that's the graph of the cosecant function. So we're going to use the sine function to graph, because we already know how to do this, and we're going to use that to graph the cosecant function. Okay? That's the domain. The range, well, what's the range? These arrows are pointing to negative infinity. These are pointing to positive infinity, but there's this gap where there's no graph. This is not part of our graph. That's the sine graph that we use to draw the graph. So the range would be everything from negative infinity, parenthesis, up to -1, bracket, and then it stops, and then it picks up again at 1 to infinity. Okay, that's it. Secant function. Well, secant is the reciprocal of cosine. It's 1 over cosine. So we're going to graph the cosine function. So start at your high point, x-axis, low point, x-axis, high point. This is the cosine function. Everywhere you have an x-intercept, draw a vertical asymptote. Okay, that doesn't take long. Just draw some vertical lines there. And then again, every place, so like right here, the graph is curving down. We're going to curve up, and we're going to follow that vertical asymptote. Right here in the middle, the graph is going to curve down and down. And then over here, again, we've got this little part where the cosine is going up as you go this way, or it's going down as you're curving this way, and our graph is going to do the opposite. It's going to go in the opposite direction. Okay, so that is a secant function. So the secant function, whereas the cosecant had like these little parabola-looking things, this one has one, and then it has these two little halves because of the way the cosine starts at its high point. This graph is going to start at its low point, and then it's going to just curve up towards infinity from there. So that is one cycle of a secant. If I drew another cycle over here, you would see this would now look like a parabola, and then you'd have another upside down and another half a parabola. So I'm just drawing one so you can kind of see the difference, that this has these whole like parabola pieces you see, and this one kind of got split. Okay? So the domain, again, all x's such that x cannot equal, well, let's see, let's pick one. Here's our first vertical asymptote, pi over 2. But then again, at 3 pi over 2, which is pi away, if you take 1/2 and add 1 pi, you get 3/2 pi. And then 5/2 and 7/2 and 9/2. It's just going to keep going. So any multiple of pi after that is going to be a domain restriction. Range, still everything from negative infinity up to -1. And then everything from 1 to infinity. Okay? All right. So let's take a look at a couple of these. These are not going to take you long. We are going to graph each function. We're going to use the graph to determine the domain and range. Okay? So for these, let's just draw one cycle. That'll be good enough. So cosecant. As soon as you see cosecant, that, 1 over sine. That's what we're really going to graph. We are going to graph a sine function that has an amplitude of 2, has a period of 2 pi over 2, so pi. There's no phase shift, there's no vertical shift, that's it. Nothing changes. We are just going to graph a normal sine graph. We're going to go out to pi. We're going to cut that in half. We're going to cut those into quarters. So this is pi over 2. We're going to go up 2 and down 2. And then I'm going to draw a normal sine graph. So I'm going to start at the origin. I'm going to go up to my high point, back to the x-axis, back to the low point, and back up to the x-axis. but then I'm just going to make a little dotted graph. Every place I have an x-intercept, I'm going to have a vertical asymptote. So there's a vertical asymptote here, there's a vertical asymptote here. The y-axis is also a vertical asymptote. And then my graph is going to curve up and up and down and down. That's it. Okay, so that's your graph. We're supposed to find the domain and range. The range is easier. Okay, it's negative infinity up to, well, this is negative 2. So the range is everything from negative infinity to negative 2, bracket. And then everything from 2 to infinity. That's your range. So what's the domain? So you need to pick one of these vertical asymptotes. I usually pick the very first, either 0. So in this case, 0 is a vertical asymptote. So that's good. That's a good place to start. So it's all the x's such that x is not allowed to equal 0 plus, and then what's the distance between them? When do we find another one? Well, at pi over 2. So and then at pi, and then, so this is a half. That's 1. There will be another one at 1.5, and 2, and 2.5, and 3. Okay, so every multiple of pi over 2, you're going to land on another vertical asymptote. Okay? All right, look at, I don't know why I have an A and an A and a B and a B, but we'll go to the second A. All right, cosecant. So again, 1 over sine. That's what we're doing. Amplitude is 2, but flipped. This one has a normal period, 2 pi, but this one has a phase shift. Ooh, let's see what that's going to do. All right, so we got a lot going on here. Phase shift is the opposite of this divided by 1, so it's just the opposite of pi over 2, so negative pi over 2. All right, so we're going to start with labeling our x and y axis. All right, period is 2 pi, so there's 2 pi, that's pi. So that means that'd be pi over 2, and that'd be 3 pi over 2. Our y-axis needs to go up to 2, down to negative 2. All right, phase shift, negative pi over 2. So first off, figure out what pi over 2 is. Here is pi over 2. Okay, so we want to go that distance, but in the negative direction. So we want to go one interval to the left, and that'd be negative pi over 2. So that's where our graph's going to start. This is a sine graph, so we're going to start on the x-axis. So that's where our graph starts. But then it's been flipped. So we are going to go down first. So we should go down to the low point, which is negative 2, back up to the x-axis, back up to positive 2, and then back down to the x-axis. So the sine graph looks like this. Everywhere you have an x-intercept, make a vertical asymptote. And then your cosecant graph is going to be trapped between those asymptotes. Up here, this little hill of the sine graph is going to look like a right side parabola because it's going to go in the opposite direction. And this little low part of our sine graph is going to look like an upside down parabola because it's going to go in that direction. That's it. That's your graph. So, domain would be all x's except x is not allowed to equal. All right, so this is what if you wanted to start here because this is where your graphs start, and you want to say that x cannot equal negative pi over 2, that's fine. I usually just start with my first positive one. So I would say x cannot equal pi over 2. And then where's the next one? It's over here, which is 3 pi over 2. So these are 1 pi away from each other. So every multiple of pi, including a negative multiple, which will get you this one, a positive multiple will get you this one, and then all the other ones will come from there. Okay, that's the domain. Range, it's everything from negative infinity up to negative 2, and then it stops and there's this big gap where there's no graph. There's a sine graph. Okay, so negative pi, or negative infinity to negative 2, and then also from 2 to infinity. Sorry, video cut out there. All right, then down on the bottom, I've got two examples of secant functions. So I'm just going to pick one of them. I'm going to pick the one that we haven't done something like. So this one over here, secant. So again, secant is 1 over cosine. So that's all we're going to do. We're going to graph a normal cosine graph. We're going to follow the same rules for amplitude and period and phase shift and vertical shift. And then once we have that graph, we're just going to flip everything and turn it into a secant graph. Okay? So the amplitude on this one is just 1. The period, it's going to be 2 pi over this. 2 pi over 3. So, dividing by a fraction is the same as multiplying by that fraction's reciprocal. So this would be 2 pi times 3 over 2 pi. Oh, okay, so just 3. So the 2 pi's will cancel and we'll get a 3. So that's what our period is. It's 3. There's no phase shift. There is a vertical shift, though. Plus 2. All right. So this graph is going to go out to 3. Half of that would be, well, 3 halves. It's half of 3, so it's 3 halves. And then I'm going to cut those into quarters. So that's like 3/4. Okay, so luckily there's no phase shift on this one. But if there was, that phase shift would probably be like 3/4 or 3 halves. It would be one of these little increments here. Okay, so I also need to shift up 2. 1, 2. So I'm going to make, so there's going to be a lot of little dotted lines here. So first off, I drew my midline. My graph needs to go 1 above and 1 below that midline, because that's my amplitude. I'm going to draw a cosine graph, so it's going to start at its high point. So this is where my graph starts. It's going to come down to the midline at the first interval. The second interval, it's going to be at my low point, which is 1. Back up to the x-axis, and then back up to the high point, which is 1 above. So this is the cosine graph that I drew. Now, your vertical asymptotes. Any place where we are crossing our midline, okay, we're not hitting the x-axis, but these midline values, if you plug this fraction, which is 3/4, okay, you're going to get a 0 in here. Okay, now you are then going to add 2 to that, and that's going to shift it up, which is why it looks like we're not hitting the x-axis. But that is going to be a value that we are not going to get a secant value for. That is going to be undefined. So any place we cross the midline, that's where we're going to have our vertical asymptotes. And once you understand that, then it's just a matter of taking our cosine graph and flipping it. This part is going to go up. This little dip is going to be our little upside down parabola looking thing. And then this over here is going to curve up and follow the vertical asymptote. So that is the graph of that secant function. Again, the domain, pick a vertical asymptote. So it's all x's such that x is not allowed to equal, so what do we say this was? 3/4. Okay, so can't equal 3/4. And then plus multiples of what? Well, our entire graph is 3 wide. This is 3 halves, and that's the gap. So notice the distance between this vertical asymptote and this vertical asymptote is 2 intervals. Well, for our x-axis, 2 intervals is 3 halves. So that's where you're going to find the next vertical asymptote is 3 halves away. And then another 3 halves, and another 3 halves. So any multiple of 3 halves, okay, now I know that one's kind of tricky, okay? So just need you to understand the concept of what's going on, but that is where the domain restrictions are. Range, So what's the range going to be on this one? It's everything from, I guess I didn't have to do the set. Oh, I guess I'm doing set builder because I wrote it that way. It's all the y's such that, let's see, I've got everything from negative infinity up to 1. And then everything from, so there's no graph, and then what is this? 1, 2, 3. Everything from 3 to infinity. Okay, didn't have to use that set builder notation, but once I wrote the brace, I just kind of went with it. So if you just wrote this part of it, that'd be fine as well. Okay, so those are the secant and the cosecant graphs. All right, so our last functions are the tangent and the cotangent. The last ones we haven't graphed yet. Okay, so I'm actually going to start with the cotangent. That one will probably make a little bit more sense to you. But I have to use the tangent, the idea of tangent, to explain cotangent. Okay, because cotangent is the reciprocal. So using our chart, using what we know about where things are positive and negative. Okay, I want to look at this little column right here. Okay, so I want to plug and I want to take the tangent of 0. So if you look at your chart, you're going to get a 0 there. Okay, I want to look at the tangent of pi over 4. Well, that's 1. If you look at your chart, you'll get a 1 there. Then I want to look at the tangent of pi over 2, which on our chart is undefined. Now, 3 pi over 4, that has the exact same reference angle as pi over 4, but we're in quadrant 2. And as you slide into quadrant 2, it's going to become negative. Okay, so tangent is negative in quadrant 2. So that's going to be a negative 1. And then when you get around to pi, pi also has a reference angle of 0, so that's also going to be a 0. Okay, so for the values that I chose, from 0 to pi, our tangent values go from 0 to undefined and then back to 0. So what does that mean for the cotangent values? It means these two values of 0 are now going to be undefined, which is why I chose these two starting points, because those are going to be vertical asymptotes. So I'm going to draw a section of this graph that's in between these vertical asymptotes. The tangent value that's undefined will now be 0. And then these two numbers, well, if you do the reciprocal of 1 and the reciprocal of negative 1, you still get 1 and negative 1. Okay? So here's what's going on with a cotangent graph. At 0, we're undefined. So this graph has a vertical asymptote at 0. It also has a vertical asymptote at pi. Okay? What else do we have? We have 0, which is right smack dab in the middle of our graph. So pi over 2 has a cotangent value of 0, so it should be right here. Now, so let's look at our x-axis compared to these values over here. This is pi over 2, this would be pi over 4, and this would be 3 pi over 4. Okay? Pi over 4 is 1. So right here, we are up to 1. And then at 3 pi over 4, we're at negative 1. So here's 3 pi over 4, and we're at negative 1. Now, here's what a cotangent graph does. It goes through 0, and then it curves up. It's going to hit that 1, and then it's going to keep going, and it's going to curve, and it's going to follow that vertical asymptote. That's what graphs do at vertical asymptotes, right? They just kind of follow them up. This side of the graph is going to go down and follow the vertical asymptote that way. That's it. That is a cotangent graph. That is an entire cotangent graph. This distance from here to here is our period, okay, I'll go ahead and write the whole word, which in this case is 1 pi. So the period of sine, cosine, cosecant, secant is 2 pi. That is one complete cycle. But for cotangent, it's just 1 pi. Okay, so this is an entire cotangent graph. and that's one cycle. You could do another cycle over here. Okay, I could just go out that same distance. So this is pi. I could go out another pi, and I could put a vertical asymptote over here. Or I could go in the negative direction. Okay, if this is pi, this would be negative pi. There'd be a vertical asymptote over here. Okay, so this little graph I drew, I could actually have like 4 cycles of a cotangent graph. Right here, it would again go through the middle. So right in between your asymptotes and right on the x-axis, that's your starting point. And then it's going to go up and to the left. It's going to go down and to the right. And that would be another cycle. So it kind of looks like a backwards like S-curve from first semester when we drew those. But that's it. That's 2 cycles of a cotangent graph. So what can we see about the cotangent graph? The domain is, well, it's going to be all x's such that x does not equal 0 plus pi and 2 pi and 3 pi and 4 pi and 5 pi. So any multiple of pi, you're going to land on another vertical asymptote. The range is all real numbers. Okay, everything that's continuous from negative infinity to positive infinity. Okay, or just all real numbers. The cotangent function is, well, this is something we haven't talked about in a long time, and we won't talk about it a whole lot, but it is an odd function, and that has to do with symmetry. If you look at the picture I have right there, if you flip your notes over, or you leave yours and I'll flip mine, it looks the same. Okay, so it's symmetric to the origin if you spin it around. The cotangent function is periodic with a period of pi, just 1 pi, 1. The x-intercepts, well, what do we have here? We have pi over 2, negative pi over 2. 3 pi over 2 is going to be an x-intercept. So the x-intercepts are pi over 2 plus, again, any multiple of pi, you're going to land on another x-intercept. And there's no y-intercept because the y-axis is a vertical asymptote. And the vertical asymptotes occur, well, the same place where we have domain restrictions. So x equals 0 plus any multiple of pi, that's going to be another vertical asymptote. Okay, so everything else about these graphs holds true as far as the amplitude and the vertical shifts and phase shifts. The only thing that's different is that our period is technically pi over k and not 2 pi. And that's how we'll draw our x-axis. Okay, so let's look at the first one. Graph each function. Use the graph to determine the domain and range of the function. All right, so this is a cotangent graph. Has an amplitude of 1. Has a period of 1 pi over 1/4. Well, dividing by 1/4 is the same as multiplying by 4, so this will be 4 pi. That's our period. This graph does not have a phase shift, but it has a vertical shift, up 1. All right, so here's what we're going to do. We are going to draw our graph. The directions do not say how many cycles we need to draw, so if we want to draw 1, we could draw 1. We are going to go out to 4 pi. Whatever your period is, we're going to go out that far. That's 4 pi. We are then going to cut that in half, so that's 2 pi. And we're going to cut those into quarters. Nothing has changed. Okay? The beginning and the end of this graph, these are going to be vertical asymptotes. And then our graph is just going to be right there in the middle. And it's going to be a little kind of backwards S-curve right there in the middle of the graph. Well, the only thing I need to do is I need to realize that my amplitude is 1, but also there's a vertical shift of 1. So I'm going to go up 1. I'm going to draw that little, I guess it's a midline. Okay, it is right in the middle of our graph. And then our cotangent graph needs to do this. It needs to hit right there on the middle of the midline, right in between our asymptotes, so at 2 pi. And then this graph, because it has an amplitude of 1, from the midline, I'm going to go up 1, so this is 1. And then I'm going to go right, and I'm going to go down 1. And then I am going to draw my cotangent graph. That's it. Okay, domain, x cannot equal 0, and then where's the next one? It's at 4 pi, so that's the multiplier. We can't equal 0, and we also can't equal any multiple of 4 pi. 4 pi, 8 pi, 12 pi. None of them are going to work, okay? And then the range is all real numbers. So the range on all of these is always all real numbers. Not a lot to do there. All right, look at B. Cotangent. Amplitude is 1/2. Okay, so our graph's going to get squished a little bit. Period is pi over k, so pi over 2. Phase shift, same phase shift. Don't do anything. It's just the opposite of this divided by this. So what's that going to be? The opposite of pi over 4, or the opposite of negative pi over 4 is pi over 4, but then we're going to divide that by 2. So if you already have a denominator of 4, and now you're dividing by 2, it is going to be pi over 8. All right, so hopefully when we draw our x-axis, that pi over 8 fraction makes sense with how we've drawn everything. So x-axis, here's pi over 2. We're going to cut that in half. That's pi over 4. And sure enough, that means that is pi over 8, and that'd be like 3 pi over 8. Okay, so that's our shift. So we have a phase shift of pi over 8, which means our normal vertical asymptotes, which would occur here and here, are going to be 1 over. That's what you want to do. Just shift your asymptotes. So we're going to have an asymptote here, and then, so I'm going to have to extend my x-axis by 1 little increment, put a vertical asymptote there, and then my graph is going to be right smack dab down the middle between those asymptotes. There's no vertical shift, so my starting point is going to be on the origin, well, on the x-axis, okay, right in the middle, right there. That's your starting point. It's always going to be in the middle of those asymptotes. And then the amplitude is going to tell us where those other 2 points are going to be. So let's say this is 1 and this is -1. Our amplitude's only a half. So from this point, I'm going to go left 1, and then I'm going to go up a half. I'm going to go right 1, I'm going to go down a half. So the only thing that changes, we're still going to get that same shape. The middle of our graph is going to be a little flatter. That's it. Nothing else changes. Okay, what's our domain? What x values, or where do we have vertical asymptotes? X is not allowed to equal, well, this was pi over 8. And then go back and look at the original. Remember before we shifted? This vertical asymptote would have been here. This vertical asymptote would have been here. So the distance between our asymptotes is pi over 2. That's how the distance between them. That's how wide our period is. Okay, that's the period of this graph is pi over 2. So that's where we're going to find another asymptote. So any multiple of pi over 2 is where you're going to find another asymptote. Okay, and then again, the range is all real numbers. Okay, so that's the cotangent graph. All right, our last function is the tangent function. So again, I'm going to make a little t-chart here, but you may notice my x values are different than the x values I used on the previous page, and there's a reason for that. Okay, I really want to use values where the ends are going to be those vertical asymptotes, because we're going to get a very similar picture to what we had on the cotangent graph. Okay, so pi over 2. So if you look at your chart, okay, so the tangent of 0 is 0. The tangent of pi over 4 is 1, and then the tangent of pi over 2 is undefined. Okay, so that means, look at these. Now, these are angles, these are negative angles. Well, all that means is they're in quadrant 4. Okay, well, what is negative pi over 4? Has the same reference angle as pi over 4, but tangent is negative in quadrant 4, so that's going to be -1. And then the negative pi over 2 has the same reference angle as pi over 2, so it's going to be undefined. Okay? So these two values, negative pi over 2 and pi over 2 are going to be where my vertical asymptotes are. Okay? Notice that they're right in the middle of our graph. So our graph, our tangent graph, goes through the origin, so 0, 0. It also goes 1, so this is pi over 4. This would be negative pi over 4. Okay, so I've got pi over 4 and then up 1, so over and up. I've got negative pi over 4 and down 1, so left and down 1. And then our graph is just going to go up and to the right, and it's going to go down and to the left. That's it. That is a tangent graph. It looks very, very similar to an x cubed or an S-curve graph. So the cotangent was kind of backwards of this. The tangent goes exactly like an S-curve. It goes up and to the right, it goes down to the left. The only difference is this is getting trapped by the vertical asymptote, where like the x cubed graph does technically get wider and wider and wider as you're moving to the right. Now, the reason why I saved this one for last, this period is the same. Okay, notice that this is pi over 2 and this is negative pi over 2. So this total distance, this period from here to here, is still pi, 1 pi. But unlike everything else, every other shape, the period went from the y-axis and then out however far you needed to go on the x-axis. But for this, the period gets split down the middle. So whatever your period is, half the graph is going to be to the right of the y-axis and the other half is to the left. And for some reason, that kind of messes with people. So if we're doing a problem and the period is 2 pi, okay, so if we had one where it got stretched out to 2 pi, you're going to go to 1 pi to the right, negative pi to the left, and that's where you're going to start. That's going to be your asymptotes. If you had a period of pi over 2, we would, again, pi over 2, you would cut that in half. And so you would go pi over 4 this way, pi over 4 that way, and again, that's where your graph would be. So that it's right smack dab through the middle, but half the period is to the left and half the period is to the right. That's the only thing that's different, and that's something that's going to kind of mess with some people. Okay? But you're going to go through the origin, and so the only way to go through the origin are these asymptotes are going to have to be to the left and the right, and that is one cycle or one period. I could do another one here. So this would be another asymptote. My graph would go up and to the right, down and to the left, so that you can draw them pretty quickly. I could do another one and another one and another one. Okay? As far as information, very similar. The domain, x cannot equal pi over 2. And then again, any multiple of pi from there, you're going to run into another domain restriction. So x cannot equal that. That means that's where your vertical asymptotes are going to be. So your domain restrictions and your vertical asymptotes are the same. So pi over 2 plus multiples of pi. The range, all real numbers. Tangent function is also an odd function, just like the S-curve. If you flip that upside down, it's going to look identical. The tangent is periodic with a period of 1 pi, not 2 pi. So tangent and cotangent have 1 pi instead of 2. The x-intercepts. Well, we've got one at the origin, and then, so the x-intercepts are 0, and then we have another one at pi, and then 2 pi, and then 3 pi, so any multiple of pi, we're going to land on another x-intercept, and the y-intercept also 0. Okay? Alright, that's it. Everything else is the same. Okay, we're going to graph that. We're going to use amplitude, and period, and phase shifts, and vertical shifts to move these things around however we need to. Okay, without having to do a T-chart for every single one. So, amplitude, 1/2. Period, there's nothing in front of the x, so that's a 1. So it is a pi over 1, or just pi. So again, period is pi over k, not 2 pi. This one also has a vertical shift up 2. So, up 2. Alright, so we're going to make our x-axis. Notice the period is 1 pi. The total width of this graph should be 1 pi. So half of that should be to the right, and half of that is to the left. So those are my halves. So just like every other graph, we have halves, and then we cut them into quarters. So we've already got our halves, and now we're going to cut those into quarters, and that's it. That's what we're going to use. The ends, those are our vertical asymptotes. These 3 points, that's the middle. That's our center point, and then our 2 other points where we're going to get our S-curve shape. This one is being shifted up 2, plus 2. So let's do that. 1, 2. So that's actually where our graph's going to start. That's our origin, for lack of a better word, okay? Because everything's being shifted up 2. And then we have an amplitude of a half. So this is 2. So this is 3, and this is 1. So from this middle, from our origin, okay, we're going to go over 1. We're going to go up a half. We're going to go left 1. We're going to go down a half. And so we're going to get an S-curve that is kind of flattened in the middle. And that's it. That is one cycle of a tangent graph. Okay, look at the last one. What do we got? We got amplitude, 3. We've got a period of pi over 1/2. Well, dividing by 1/2 is the same as multiplying by 2, so 2 pi. This one does not have a vertical shift. It has a phase shift. Okay, phase shift is the opposite of this. So pi over 4 over this, 1 over 2. That's it. What the heck does that mean? Well, it'd be pi over 4 times, so flip it, 2 over 1. Now, the 2 and the 4 are going to reduce. Okay, that 2 and that 4 are going to reduce. You're going to get pi over 2. That is our phase shift. All right, so let's see what that means. First, let's just focus on this. Okay, we've got our x-axis. Our period is 2 pi. Our complete one cycle period is 2 pi. So 1 pi should be to the right and 1 pi should be to the left. So we're going to call that pi. We're going to call that negative pi. Okay, so those are our ends. Normally, there's a phase shift, so they'll change a little bit. Okay, those are our ends. And then I need to cut those into quarters. So those are our halves, and now I need to cut it into quarters. So this is pi, this is negative pi, this would be pi over 2, this would be negative pi over 2, which just so happens to be what our phase shift is. So pi over 2 is 1 to the right. So our entire graph is going to shift 1 to the right. Okay? So this, what would have been a vertical asymptote, now is over here. That means this that would have been a vertical asymptote is also getting shifted over 1. So I need to extend my x-axis. What else? That's it. Okay, amplitude is 3. 1, 2, 3 up. 1, 2, 3 down. So your starting point, there's no vertical shift, so your starting point is going to be on the x-axis, but there's that phase shift. It's going to start right here. It has to be right smack dab in between your two asymptotes. So that's our first initial point. Okay, that's what would have been the origin, but everything's being shifted. And then from here, I'm going to go right 1, up 3, left and down 3. So this S-curve is being stretched out by that amplitude. And we get that. Same shape. Maybe yours is a little more vertical. Mine looks like it's slanting a little bit. I apologize. Okay, it's just how I'm looking at my paper. Things got slanted. I also asked you in the directions to find the domain and range. Now the range is all real numbers, okay, for both of these. Domain, again, you're just looking at where your asymptotes are. So we have a domain restriction at pi over 2. I always, if you want to start at negative pi over 2, if you want to read from left to right, you knock yourself out. It's all the x's that do not equal pi over 2. And then your period, that's the length between your asymptotes. So every multiple of pi from there, you're going to land on another one. Over here, the domain x is not allowed to equal So what's this? So maybe in this case, this one is the easier one to read, right? Because I've got it, negative pi over 2. Well, this is pi over 2, pi, that'd be 3 pi over 2. So x cannot equal 3 pi over 2, and then any multiple of 2 pi from there, you're going to land on another one. Okay? And then the range is all real numbers. So that's it. Those are all our graphs now. So take a look at your worksheet. Let me know if you have any trouble with this. Okay?